So welcome to our session again, and today you have a solved question on electrochemistry that's involving the electrode potentials. These are some of the common questions which normally comes from this section, and they are highly tested. So the question states, below are standard electrode potentials of some elements, and these elements have been given by their real names. So for element number 1, that's magnesium. Magnesium has the E value or E naught value of negative 2.36. Element number 2 is zinc. Zinc, they have an E naught value of negative 0.76. Element number 3 is silver, and silver has been given the E naught value of positive 0.79. And the last element is copper, whereby it has been given the E naught value of negative 0.36. So before you solve this equation, you must study it and analyze it first. So you have 4 elements, and the potentials have been given. Now you have to analyze the equation by identifying, from our last session we said that you must identify first the strongest reducing agent, the strongest oxidizing agent from these values given. So among these 4 elements, the highest negative, we say that the highest negative, that is, will give you the strongest reducing agent. So you are analyzing the equation. Then the highest positive will give you the strongest oxidizing agent. In this case, we have only one, that is silver, that is strongest oxidizing agent, before reading the equation. Then we say that the strongest reducing agent, that is oxidized species. So meaning this is our strongest reducing agent. This one will be oxidized. Meaning it will lose electrons. Then the strongest oxidizing agent, this one will be reduced, meaning it will gain electrons. Now we come to our question. Question number A, Roman 1. Identify, Roman 1, strongest oxidizing agent. The question becomes very easy because you have already analyzed your statistics given there. So you say that the strongest oxidizing agent, that is silver, with a positive 0.79. So you say that the strongest oxidizing agent, you just write silver, Ag. That is silver. You don't write the ions. These are the ions. You write the element, that is Ag. If they say identify the E value of the strongest oxidizing agent, now you give the E value. So you say that the E value will be positive 0.79. Now you are given the value. That is Roman 1. Strongest reducing agent. Strongest reducing agent. And from your statistics, you will analyze that the most electronegative, that is magnesium, is the strongest reducing agent. So just identify the element. You say that strongest reducing agent, it is magnesium. I remember your first letter, that is M, must be in capital. And if you are told to identify or to write or to identify the E value of the strongest reducing agent, that is to say that the value now the value is negative 2.36. This is now the value. But if that is say the strongest reducing agent, that is become magnesium. On the same, you'll be also be asked to identify the elements when combined will will give the highest EMF, electromotive force. So among these elements given, the four of them, which one will give the highest electromotive force when combined? And we said that in our last session that the species that normally gives the highest EMF when combined is the strongest reducing agent and the strongest oxidizing agent. Those two when combined will give you the highest EMF. In this case, we shall still go for our silver and magnesium. When you combine this silver and magnesium, will give you the highest EMF. So you just say that elements they are silver and magnesium. These two when combined will give you the highest EMF. We can calculate it. For instance, we say that E reduced minus E oxidized. That was our formula. In this case, our E reduced, that is positive 0.79 minus negative 2.36. So when you combine these two, they will give you the highest EMF. So in this case, they will give you what? These are positive here. So that is 513 volts. The word volt must be there. This is the units for electromotive force. So that is the highest EMF given by combining these two. So if you are asked which one will give you the highest EMF, you take the strongest oxidizing agent minus the strongest reducing agent, and your answer must be in positive. If you get your answer is becoming a negative, it means you have done it the wrong way. So that was question Roman 3. Then here they can still ask you if you add here hydrogen plus electron, this is a gas, hydrogen, giving you hydrogen gas, that is 0.00. Hydrogen gas is always 0.00. Take note of this. And if you see an element or an electrochemical cell or a species with a 0.00, that one is called so in this case hydrogen is called a reference electrode. So if you see an element or a species with 0.00, that one is called a reference electrode. Why? Because it is having an electromotive force or an E0 value of 0.00. It cannot be just hydrogen. You can now be given letters like C positive plus electrons. You get C gas with 0.00. If you have been given the letters, you will be asked which one is hydrogen gas. Just give the letter with 0.00. That is your hydrogen gas. If you are told to give a reason for your answer, you say because it is a reference electron. It is between a positive and a negative. On a number line, you normally have 0.0. Then this on the left hand side is a negative. On the right hand side, that's a positive. This one is a reference electrode. It's between the positive and between negative. That's another point you should note, that in any of the electrode potentials, 0.00 is always a reference electrode. Don't use it to calculate electromotive force or to calculate the EMF. That is another point you should note. Lastly, if you are told to draw an electrochemical cell which will produce the highest EMF. Now you draw it. We say that negative 2.36, that is oxidized species, and positive 0.79, that is reduced species. So you want to combine silver and magnesium, but now on an electrochemical cell. How do you go about it? I just use our data here. So our data is there are these two values we are interested in. This magnesium, this is silver. This was magnesium. This is silver, argentum. So you say that now the oxidized species will be at the anode. The word anode has O. O means oxidized. Reduced species will be at the cathode. Now when drawing, you say that you draw your two beakers. These are two beakers, and you must connect your two electrolyte. You must connect them with a salt bridge. Remember, salt bridge is it is combining these two electrolytes. We say that it has two functions: completing the circuit and balancing of the ions. So this is your electrolytes. Then we have the electrodes. You have electrode here and electrode here. And this electrode, they have been connected using a connecting wire. On this connecting wire, we normally connect there a voltmeter. A voltmeter it will be used to calculate the EMF. Now, on your left hand side, this is your anode. This is your anode. On your right hand side, that is our cathode. So electrons will be moving from anode to cathode. These are your electrons. Then on your anode side, say that the anode side that will be our anode, will be our magnesium. So this is our magnesium. Then the electrolyte will be the same as the ions of the electrode. So will be magnesium ions. Then this will be our silver ions. This will be our silver electrode. Then we say that this electrode, the concentration must be 1 m with 25 degrees Celsius as your temperature. So this is your electrochemical cell. So you note that the oxidized species is in your left hand side, that is the anode. The reduced species will be at the cathode, that is on your right hand side. That's how to draw an electrochemical cell of the highest EMF. Take note of that. So we shall look at another example in our next session. YouTube channel, continue subscribing and following our sessions in different areas. Thank you.